Welcome back. We're moving on to part 2, which is entitled, That Doesn't Make Sense. Have you ever had that moment when you're solving a problem and you look at your answer and you start thinking to yourself, that just doesn't make sense? That's a warning sign that you should go back and take a look at your assumptions. All right, so let's take a look at this problem. All right, the scatter plot on the right is an interesting one. All right, so we're looking at the average pounds of ice cream consumed per person, and then we're looking at the Florida murder rate per 100,000 in the population. What do you notice as the average pounds of ice cream consumed is increasing? What do you notice is happening to the Florida murder rate? I'm going to give you a moment to answer. What I notice is that as the average pounds of ice cream consumed are increasing, the Florida murder rate appears to be increasing as well, and that would be worrisome. And after viewing it, Maria commented, "Oh my, ice cream makes people kill each other. How awful." Janet seemed more perplexed and thought out loud, "That doesn't make sense." I want you to think about who you agree with. Do we really think that that as the pounds of ice cream consumed per person increases, that the murder rate in a state would actually increase? Does that seem to be like a cause and effect relationship? For me, I would probably agree with Janet. That just doesn't make sense. Because my counter question is how? Right? How could ice cream sales increase the murder rate? Right? How could that actually happen? So my guess is that this is just an incidental relationship as opposed to an actual cause and effect relationship. Now, the strength of the relationship seen here does seem to be strong. In fact, I'd probably estimate the correlation coefficient to be between probably 0.8 to 0.9. It might even be just a little bit higher, but if you draw the oval around these points, the points aren't all that scattered around this line. They're fairly consistent. And the direction is definitely positive, which means that as x increases, y is increasing. And it does seem to be linear. And I don't really notice a whole lot of unusual points in here. So in order to determine how we should talk about this information, let's talk about the idea of correlation versus causation. All right, correlation measures the strength and direction of a linear relationship. Now, it's really important to keep in mind that this R value is only going to be valid for linear relationships. We cannot calculate it with anything that's not linear. All right, so this number becomes invalidated if we're looking at any sort of curved or nonlinear relationship. So we only really use the word correlation when we're talking about a linear relationship. Otherwise, we revert back to the term relationship or association. All right, that's a more generic statistical term for these seem to be connected in some way, but we don't know how or why. Now, causation implies a cause and effect relationship, that whatever is changing in the x is causing the change in y. Right, so causation implies a cause and effect relationship. And the important thing to keep in mind with statistics, when you're trying to prove a cause and effect relationship, typically you have to do some sort of well-designed randomized experiment where you randomly assign the treatments. So you'd have to randomly assign individuals to eat certain amounts of ice cream to see if they go off to kill people. One, that doesn't seem very ethical. Two, the experiment itself seems kind of ludicrous. All right, so I highly doubt that we actually have a cause and effect relationship here. Now, lurking variables. Why would this relationship exist? And that's more likely down to lurking variables. Lurking variable is a variable that, so it's a variable that is not among the explanatory or response variables. But may influence the response variable. All right, so is it correlation or causation? All right, which one are we going to go with this? Is it correlation or causation? And let's explain our reasoning. Now, I'm going to give you a moment to go ahead and provide your own answer for this. My take on this is that this is correlation because there is an underlying lurking variable that might actually cause both of these to increase. More people tend to crave ice cream in the summer months. And during the summer months, it gets hotter, people get crankier, they're outside more, so they're coming into contact with each other more. And as people get cranky in the heat and tempers boil over, the murder rate is more likely to increase. So it probably has more to do with the environment around the individuals perpetrating these crimes as opposed to ice cream actually being consumed, but ice cream being consumed could be a telltale sign of what the underlying lurking variable might actually be. All right, so I'm going to say correlation And the main reason I'm really saying correlation for this is that we need a well-designed experiment to determine causation, and we don't have one. All right, that's the true key difference here, but you could also describe it in terms of what you think might be a lurking variable and how it might affect the situation as well. That's a really good way to kind of refute these kinds of claims where someone just goes off on a tangent and decides because there seems to be a relationship here, it has to be cause and effect. There are relationships other than cause and effect. And that's really important to keep in mind when you're actually writing conclusions based on data. You never want to misrepresent what the data is actually allowed to say. That's when you get into situations like we have currently going on in the country, where a bunch of people are misrepresenting data, leading people astray, and suddenly there's this whole misinformation thing happening. All right, so it's really important to be to use integrity when dealing with data. So I'm going to say correlation because we need a well-designed experiment to determine causation. All right, now just like yesterday, I'm going to demonstrate how to do one of these at the bottom here, and then I want you guys to go through and to try the practice together. All right, so I'm going to have you work on this in your groups. And if you're watching this separately, if you're not in my classes, feel free to pause this and try some of these others and try to work through them. And if you are in my class and you're watching this outside of the class period, then you'll want to continue on with this paper and complete the rest of the notes to be able to turn them in. All right, so let's take a look at this first one. All right, we're back to the old faithful eruptions. All right, so we have our eruption duration, which was our explanatory variable. We have our waiting time between eruptions, which is our response variable. And if linear, estimate the R value. Now, this one appears to be linear, and I would say that it is approximately, let's say 0.8 maybe. It's somewhat scattered, but it's really distinct, the direction of this. And notice I'm giving this a positive 0.8 because this is a positive line that's sort of drawn here in the middle. Now I'm going to say correlation for this, because a possible lurking variable would be chamber pressure. Specifically, the pressure of the magma within the volcanic chambers that Old Faithful is connected to. Now, if you don't already know, Old Faithful is connected to the Yellowstone supervolcano system. It's why there are eruptions. It's actually pressure leaving that whole volcanic chamber system. So as it needs to alleviate pressure, it erupts. My assumption is that the more pressure, the longer the duration, as it lets off more steam, then it might be able to wait longer before letting off more steam, as that system is trying to kind of work through its grumbles. All right, now these two quantitative variables, the reason I'm saying correlation is that these two are most likely both products of the other variables that affect the stability of this volcanic chain. Now, chamber pressure might not be the only lurking variable that we're dealing with. I'm not an expert in volcanic eruptions or volcanic systems by any means, and I'm not an environmental scientist. But knowing that there is this potential lurking variable, I can say that the two quantitative variables meaning the eruption duration and the waiting time between eruptions, are more likely products of other variables that affect the stability of the volcanic chain. All right. Now I want you guys to go through and try to do the same type of work with these other graphs and on to the next page. All right, so I'm going to break you out into your small groups. Go ahead and discuss this, and we will see what you come up with. Thank you for listening. I'll see you next time.